1000 nanometers. It's 1000 nanometers. Yeah. I'm not able to get this. Okay. From 1000 nanometers, from 1000 to 1000 to, you see here, up to 1 millimeter. It's a microwaves. It's a microwaves. What's happening? It's again, it's coming. Move the window away from. Yeah. Sorry. From 1000 nanometers to, just you can see between this 1 millimeter, we have a microwaves, and after that 1 millimeter, that will get 1 meter, and again from 1 meter onwards, we see that is a broadcast waves. That's a 1 kilometer, that is indicating the 10 to the power of 3. When we go towards the left, and then when you come into the towards right, it's a completely very dangerous waves we have here. It is again approximately nearby the 10 to the power of -9. It's a 1 nanometer, that is indicating as a X-rays. Between these X-rays and the visible light, we see visible light means approximately that is a 400 nanometers. From 400 nanometers to up to 1 nanometer, between this area, we will see the ultraviolet rays. After that, from 1 nanometer to up to 10 to the power of -12 meters, we'll get the gamma rays, and then afterwards it is going to start as a cosmic rays. Okay, this is the electromagnetic spectrum. Then based on this, so we have to see the different types of spectral bands. Bands we see. Those are like as the terms we calling, that is as a spatial, and one more it is a spectral, and another one it is a radiometric resolution. Radiometric resolution. See, based on this only, we will divide it. The spectral resolution. What does it indicate? The spectral resolution. Yeah, spectral reflectance. This is. That's also we have seen in previous class. Was not mentioned. Maybe system. Yeah, wait, please. Yes. Yeah. Based on that spectral resolution, you see here, the spectral resolution is defined as the ability and it's distinguish between the two objects very closely. Objects what we are identifying, the closely objectives which are having the space and an image, that we can able to identify based on that resolution. Even though it is a depend on their sizes. If it is a very small size also, we can able to identify. Based on that, the spatial resolution, it is very complex and which can identify that depend on the remote sensing of polar regions and which can be defined its very smallest object and that can be detected and distinguished from point to point. So one more. Please wait. Yes. Yeah. In the spatial resolution, it is speaking about the how much digital in the photographic image and how much it is going to be visible with our human eye. The ability it is a result to separate the small details, or maybe it is a one way of describing the special object what we are describing, and that is called as a spatial resolution. The spatial resolution, the images which are acquired by the satellite sensor system, and it is usually expressed in a meters level. And again, yeah, meters level, and there is a one principle for that one, that is as a HLD, that is HL by D, sorry, HL by D here. H denotes that the height, and L it is a wavelength, D it is the diameter of a specific object in a particular location, and it's having a lens. The spatial resolution of images which are acquired by satellite sensors and the results of values we can express in meters. Of course, just for example, if you can say the Landsat satellite, and it's having the 30 meters of resolution. That is describing about the between the two objects. The 30 meters of a objects, maybe it's having a long, or at the same time it is a wide. That maybe it is a settle down the side by side. But if you take the Landsat image, but we are not able to measure. But the differentiation or the difference between the one object to the another object, the distance it should be must and should that has a 30 meters. In other sensors which are having the very lower, or maybe it's having the higher resolutions, and that's also depend on their that's also depend on their object, and while it's taking the photograph or while it's taking the picture with the sensors. Yeah, here it's mentioning the Landsat sensors, the spatial resolution and that temporal resolution you see here. The first one, it is a spectral resolution. In a spectral resolution, it's a corresponding with the object to the sensor. We know that blue it is indicating 0.45 to approximately 0.52. The range it is indicating as a it is indicating that blue color. And second one, it is a 0.5 to 0.60. It's between the 0.5 to 0.6, so that it is indicating as a green. 0.63 to again 0.69, the third one, this one. 0.63 to 0.69, it's indicating as a red color. Because of, again, just you can remember that this electromagnetic spectrum of visible colors, that's a range 0.4 to 0.7 micrometers. With 0.4 to 0.5, it is indicating the blue. 0.5 to 0.6, it is indicating the green. 0.6 to 0.7, it is indicating as a red color. So that as per that, now you can compare the measurements here. The first one 0.5 to 0.45 to 0.52. Second one, it is a 0.52 to 0.60. And third one, it is a 0.63 to 0.69. So, so that the top three colors, you see, the top 1, 2, 3, these three colors, it's indicating between the visible ranges of 0.4 to 0.7. Again, next fourth one, that's a 0.76 to 0.90. It's a far nearby the infrared, and so that is it is indicating as a NIR. NIR means near infrared color, near infrared waves. This is, and fifth one, you see 1.55 to 1.75. 1.55 to 1.75, and again the sixth one 0.8 no, 2.0.08 to 2.35. That is also belongs to the MIR. MIR means mid-infrared rays. Mid-infrared rays. So we compare the reference value. So where it is that. And final one, it is a TIR. It's a total infrared, and it's the topmost. And again, coming to the spatial resolution here. The spatial resolution, it is speaking about the width and the height of the of the object. We are taking the photograph that is maybe around the distance from one object to the another object. It is a 30 by 30. It's a 30 by 30. So then some temporal resolution or a spatial coverage. You see here temporal resolution, it's a common for all 16, 16 and 18. Or spatial coverage. Approximately it is 185 into 185. That's a long and width. The altitude is maintaining that 705 kilometers of a height. It's from that height onwards, it has taken photographs and it has a sense of the data. Okay, then it's a spatial resolution. Just you see the objects here. It's a planimetric data. This planimetric data is consisting of buildings, roads, and other driveways. Yes. Here there is no mention. I mean, here we didn't mention any height here. And resolution also we didn't mention here. It's taken a photograph in the field of instant view. So suddenly if you take the photographs, it will come like this. Then if you mention specific resolution. If it is a 80 meters, the distance between 80 meters from one object to another object, and it's a cover the 80 meters of area, then you see, and you check the background. You check the again background when it is 30 meters. Then 10 meters of resolution with a spot. You see the differentiation, the background differentiation of the same image. Here we didn't mention any, I mean, it's a normal photograph what we have taken. A little bit the height was decreased, 80 meters. And next come down towards 30 meters. And next come down to 10 meters. You see the differentiation, the background differentiation you see. And then 1 meter resolution. On a 1 meter resolution, if you take the photograph, the background you can see. It was captured all the things. Yeah, sub-meter data. You see, we compared from first onwards, the development you can see. It's nothing appear in the background. Only just we have identified the planimetric data. The roads are building or driveways or whatever. And next is 80 meters. If you can decrease, then we'll get a little bit spotted, different colors. And 30 meters. That means if you go into the down, the resolution, it is going to be in the resolution. If it is going to be decreasing, then the pixel sizes, the pixels, you see this back side, the background of this picture, you see small cells we can able to identify. The grids, small grids, you see here, the small grids we can identify. The small grids, these are all having a different colors. Those are all the tones we are calling. I'll tell you later what it is a tone. Based on this resolution of a height, the background it is going to be developing. The pixels were developed. And if you can see, this is a very closely of that area. That means if you're coming down towards surface, and you can focus on only one object. Yes, we can see like this. One more thing it is here. The pixel sizes are very important. If you, example for if you can say the mobile pixel sizes, and at the same time, if you can maintain the distance. So if you're taking the picture with 15 megapixels of a camera, and it has a capability to take the picture about around 100 meters or 200 meters. And if you can zoom it after have taken the photograph, and you can zoom it, even though it's showing the clear picture, because of depend on the pixel sizes. Pixel means photographic, photoelectrical cell. Okay, what happened? Any issue? Is it audible, my voice?
Yes, sir. Maybe she did not connect her audio.
Is it visible, this PPT?
Yes, sir.
Okay, someone, let's say what it is that. Everyone hear any voice? Yeah, Dinesh.
Sir.
What happened, please? Why did you raise hand?
Oh, no, sir. Actually, it's present, sir.
Just you keep in mute.
Okay, sir.
Okay, thank you. Yeah. Okay. Yeah. Okay, if you're taking the photograph with the 15 megapixels of a camera, and you have to maintain the distance that's supposed to 200 meters. And after you're taking the photograph, just you can check it. Yeah, okay. Maybe if it is clear. And again, the same area and you maintain the same distance, but you reduce the picture sizes. Maybe that is around 10 megapixels of the camera if you're taking that. And again, you can see the differentiation from a previous one. We'll get the differentiation definitely because of what's happening here. We are reducing the pixel sizes here. In previous case, we have a 15 megapixels of camera. You have taken the photograph, and the same area with maintaining the same distance, and you have taken the photograph with the 200 meters of distance, and then you check out the differentiation from 15 meters to 15 megapixel to the 10 megapixels of the camera pictures. Okay, what's the differentiation between that? Yes, the clarity. I mean, the picture clarity will indicate. So what's happening? The pixels are reduced, so automatically the energy it is reduced. So if you're maintaining the same distance, and we didn't get a clarity of all the objects because of the pixel sizes means the light it is going to fail you there. The light it will become from the pixels only. So from the pixels, from the pixels, the light it will be released, then we'll get the clarity, then we'll get the picture clarity. So if we can reduce that one automatically, the clarity is going to be also lost. So that's one thing. And here also the same principle we can apply in a resolution. If you wanted to focus only one object, focus only one object, and within that limit we have to take in the photograph. If it is exceeded that, that means the other objects will be impacting on the same picture, and then the clarity is going to be lost. So then, if you are focused the only one object there, okay, suppose if you are focused the this object, and you have to, you will take the photograph from nearby these areas or with maintaining the distance. If you're maintaining the height, maybe if it is increased, okay, it's mentioned. The satellite, maybe it is a land satellite, maybe it's maintaining the distance approximately 80 meters of resolution of a grid cell. This one. The grid, it's consisting of 80 meters and 80 meters and 80 meters. So the surrounding areas are within the 80 meters of square area, we'll get the picture. That means it is applicable only within the restricted area and how much area you are going to focus and how much area you are going to cover with taking the photograph. Till that area only will mention in a scanner, and then it will be focusing on a particular area and it's extracting the data. If it is 30 meters, you see, at outside, the possibility is it is indicating the 80 meters, it's covering the 80 meters of that area, and then if it is a 30 meters. 30 meters means within this 30 meters of a square meter, 30 square meters of area. Within that radius only we'll get the data. Let's see. Just we can zoom it like this, and we can able to see that. Yeah, it's a 10 meters. It's a 10 meters of a resolution. Just wait, I'll show you that grid. Wait. Yes, you see, this is actually a surfer map. I'm doing here zoom in and zoom out. It's not coming. Wait, I'll show you. I'll take another map. Yes. Yeah. This is a grids. These are all the grids. Just if you can click here, these are all you can see. It's indicating the plus. It's a surfer tool like a GIS. This is also, but not pure GIS. Whatever data we have in our hand, with the using of this one, just we can go to the files and we can open that. Each grid, it is indicating the each pixel, and it is indicating the longitudes and latitudes values. You see, just I'm clicking here. You can check here X and Y coordinates, these two, and we have a 3 coordinates X, Y, Z. It's a 3-dimensional picture. It's changing the values if I'm clicking like this. Let's see. So here, and again, it's containing pixels. So based on these pixel sizes and based on these pixels, just you can zoom in. It's a 3-dimensional picture. Z, we cannot able to see the Z values here. It's an average value. This plus, it contains the plus, it contains cells. Cells means pixels here. So if you can zoom out, yeah, you see, these are all the values of Z. These are all the contour lines. I'll tell you later contour lines. Contour lines are different from this one now. I'll tell you. Okay. When we are moving, zoom in and zoom out, just you can see the clarity of the picture. These are all the grids. This one 1 pixel, and this one, and this one, and this one. It's making as a complete grid. It's making as a complete grid. So that you can see here one picture format, it's consisting of how many grid cells? So many. And again. Wait, I'll show you one more. Just. Oh, yeah, yeah. Yes. If you select this is and see this tonal colors. You see these tonal colors. It's a blue. It is indicating the water bodies, and red it is indicating the dry area. Okay, that is a no need. It's application only. But here, my intention it is the group of pixels. Each cell, it's containing the with the limit of the range colors. So that's depend on their resolution. If you can zoom in, we get a clear picture. Or if you go into the zoom out, the picture clarity it is going to be less. Similarly, in remotely sensed map also. We can go into the deep or we can go into the zoom in, depend on the bandwidth, the pixel sizes is going to be increased. So as per that, we can see the colors. Yeah, coming to the topic again. Yes. Yeah, this is like that previously what I have shown you, maps. Yeah. Again. It is a selected satellite footprints it's showing, depend on their different resolutions and different heights to take the photographs. Each one, this is from the black one, it's covering the large area, and it was taken by the 170 kilometers of a height. And second one, it is a 145 kilometers of a height. And again, if you can zoom it, we'll get the clear picture here. We get a clear picture. Just example, again, we see if it is a Google map. I hope maybe it's not opening. Just wait. Yeah, sorry.